Okay. Welcome everyone. I am so happy to see you all here. My name is Julie Johnson and I'm the Executive Director of the Hitchcock Center. Just coming off parking duty. Part of being a living building is that we have very limited parking. So we're doing some creative parking maneuvers out there. It's such great to have such a big crowd here. So welcome everyone. I hope you have had a chance to, I see very familiar faces, but some of you may be new here to the Hitchcock Center, and I just want to invite you to participate in our monthly living building tour program. If you want to learn more about this building, it's a net zero energy building. It will be a net zero water building. It's a non-toxic building. And it's been built to the highest standard of green building in the world. So you're in a very revolutionary building, and you are here because you care about net zero energy, and we're just very excited to have Ellen here to talk about the topic and really engage in thinking about policy as well as practice. And I'm very happy to introduce Ann Perkins, who is also part of organizing this great program, and she's also a board member of the Hitchcock Center, so thank you, Ann.
Thank you, Julie. So I want to thank you on behalf of the group that brought the Zero Energy Bylaw to Amherst. That would be a group of people from Mothers Out Front, Climate Action Now. We also want to thank the League of Women Voters and the Town Sustainability, Sustain Amherst program, who co-sponsored this event. And I'm really delighted to introduce Ellen Watts, who has come to us from Boston to speak tonight, and I will tell you her credentials. She is the president and co-founder of Architerra, a Boston architecture and planning firm dedicated to climate action through design excellence. This innovative, sustainable design practice has been recognized by over 30 design awards, including 2 American Institute of Architects Top 10 Green Building Awards, and top honors in the Boston Living with Water competition. With degrees in architecture, real estate development, and government from Harvard, MIT, and Smith College, respectively, Ellen is the driving force behind Architerra's focus on zero net energy buildings and resiliency planning. Ellen formerly chaired the Massachusetts Governor's Zero Net Energy Building Task Force, served as president of the New England Women in Real Estate, and was the principal investigator for the State of Sustainability in Higher Education, funded by an inaugural research grant by the Boston Society of Architects. More recently, Ellen led professional Boston delegations to Copenhagen, Denmark, and Hamburg, Germany to study climate neutral and climate adaptation strategies. Welcome, Ellen.
I'm delighted to be here. I want to say that you all have created quite the buzz when it spread to Boston and my hearing that Amherst had passed a bylaw, 123 to 54, to mandate zero energy performance for its municipal buildings. Many people cheered for your courage and your commitment. And I know that there are many among you who wonder, is it practical? And if you think it's practical, maybe you wonder, is it really affordable? And if you're already here thinking, I know it's practical and I know it's affordable, you may still be wanting to know, what are the best ways to approach it? So I'm hoping to offer a little something for everyone here, no matter what camp you fall into. I first want to talk to the skeptics. And I'm not going to ask you for a show of hands, because I really don't want this to be divisive. This wants to be communal here. But I myself would be talking to you differently if I had been talking to you 10 years ago than talking now. You can know that this is achievable because there's empirical evidence. There are zero energy buildings across the United States, all different kinds of projects. There are many databases, many white papers, many case studies. Just go look at the resources. You can look at the Federal Department of Energy. An intern architect, one of Steve's grads from the architecture program at UMass Amherst, noted one of them was just entered 6 days ago. So it's a database of about 180 now, I think it is. Very, very low energy / zero net energy buildings. Another database, there's a nonprofit called Seventh Wave, I believe it is, in Wisconsin. They do a really good job of digital case studies on zero net buildings, and it's called HPB, High Performance B, HPB, hard to say. Mark Sternick will recognize that. There are also numerous other organizations in the Northeast with a bigger catalog of the local exemplars. Nessie would be a good place to start for that. There may be some people who have wondered about the quickness of the adaptation of some of the newer technologies that are going into this building. These types of buildings. Let me just say that there has been a revolution in many, many components that make this a different discussion today, and your timing's so perfect. In the last 3 years alone, in our practical experience, we're architects and planners, solar panels, for example, have dropped in cost by half, while increasing in efficiency by 50%. So we need far less roof area and way less money than we did to cover the energy demand of buildings that we had on the board starting 3 years ago. Additionally, light-emitting diode lighting, which was first incorporated in our buildings 10 years ago. A prototype in plastic was hand-carried on a beach towel from Long Island, from a lab that then sold their business to Philips. And that light was put into a building experimentally, only with the signature of the president of the company they would indefinitely warranty, whatever went wrong with that. We've now designed a number of buildings, I'm going to show you one of them, with 100% LED lighting. What this means is not only significant energy savings, but very low maintenance costs. So instead of having maintenance staff changing lamps every year, and on rotation, of course, they would do it just to be efficient about it, more often than the lamp life, you've got a 50,000 hour, lamp life. So revolutionary things are happening. Same thing is happening in battery storage. We don't quite yet have commercially available, right-sized for large non-residential buildings, batteries to serve as the backup for the energy supply. We're still using the grid as our primary battery, if you will. So where we put the overproduction from wind or solar and where we draw from when the wind isn't blowing, the sun isn't shining. But soon we'll be able to have batteries. And that's going to be a big economic boost to these projects. Why? Because right now, if you go through the pain of getting a net metering agreement with the utility, you get in there under the cap and you go through the bureaucracy of doing all that, you don't get a dollar for a dollar. They'll sell you energy for a dollar, but they'll only give you 80 cents on the dollar. So when you'll be able to bank your own energy right there in your mechanical room, right on your site, you're going to be golden. And these batteries are starting to become commercially viable for development communities that are in island settings and so on and so forth. We're not yet using any of them in our work, but whereas we've long been designing buildings that they can't afford a PV array quite yet to design them to be solar ready, we're now recommending that we design everything to be battery ready. So technology is changing the equation for energy from one of mining for fuel. You know, ever since mankind was trying to get light and heat from wood, it's been about excavating for fuel. We don't have to do that any longer, and thank goodness, because a lot of extraction just becomes more and more and more expensive over time. Technology works just the other way. If you look at the cost of solar panels, they've gone from like here, I'm in the 1970s now, to like here, and they're going down. So over time, technology drops in cost. So this is the right time. Wind also has become tremendously more affordable over the last 10 years. I'll tell you a little anecdote. One of the projects we designed is called the Wind Technology Testing Center. It's on Boston Harbor. It was a first of a kind in the world when designed. It is a structural testing lab for really long turbine blades. Day one, that project opened in 2011. The blade was 35 meters long. I was in there last week. The blade they were testing was 62 meters long. The significance of this is that the cost of wind-generated energy falls exponentially with the length of the blade. And thank goodness we designed this facility for 100 meters. That's longer than a football field. That is how much efficiency is being gained. Now, there are lots of other technological innovations that are going into the composites that create the blades and all of the other components of turbines. But I just want to talk about the promise of technology as well as the empirical evidence to talk to the skeptics about, is this possible? Yes, it is. You have only to look and to do a little research about the technology that's going into this. Okay, so then let's take cost. I'm talking to everybody here. We have to make good use of our capital resources just as much as we have to make good of our natural resources. There are lots and lots of ways to think about these buildings as being very, very good investments. And I'll show you some examples of the calculations that went into justifying returns on solar panels and returns on district energy plants. But that's how you have to think about them. They are affordable for standard budgets if you start with the goal and an integrated team and an integrated design approach. And I'll show some examples to that. A common misconception is that cost and performance are linked. You can build a very expensive zero energy building, but you don't have to do that. If you start with a conventional budget for the project that you're going to build anyway, by doing a number of things, you can keep that cost where it wants to be. First thing you have to do is do the stuff that's for free. I'll give you an example. One of the most effective things you can do to reduce a cooling load is to put on a light color roof, high albedo roof. That's a choice. It comes for free. You can do that on the interiors too if you selectively distribute your lighting fixtures. You can choose the most wonderful LED fixtures almost willy-nilly without regard to cost. If you space them and use the walls and the ceiling as reflectors for them and hit a nice gradation of lighting effect, going more for lighting quality than lighting quantity. A lot of buildings are quite overlit and badly graduated. You can have absolutely wonderful lighting solutions for less money. You can achieve savings, even using slightly more expensive fixtures if you design it right. And then there's the important goal of not just using what's for free, not just actually saving energy, but trading it off. We have not designed a building in 20 years with other than triple glazing. Not double glazing, triple glazing. We do that because we also carefully work with our engineers to right-size the mechanical systems for the added benefit of that building envelope that's higher performing. If you trade it off, spend a little more on something that's first cost and perennially get the savings from that and offset it with a redesign offset, you'll make that budget. So that is the story on cost, and I'm going to have in the slides some information about performance and cost and some graphs that show you how dissociated these things are. So many parameters have a bigger impact on cost than performance. The leading one is site. If you need a building, but you come with a 4-acre site, and oh, by the way, we need a 2-acre public park along with it, and we don't have any utilities on the site, you've got to run those to the building, that's going to be a different budget. And the coda to that might be, oh, and by the way, there's hazardous waste. We've had projects where there is literally $2 million spent before there's even any work done toward the building. The second thing that's a real driver for cost, that's kind of in your hands as the client, you the town, and your design team, is building efficiency. If you're building a rote cookie cutter office building, you're pretty much going to be assured by rules of thumb that it'll be 80 or 90% efficient. But other buildings that are a little more freestyle, let's say a community center, where you don't even know by that phrase, community center, what's in it, what's the program for it, the building efficiency could be 50%, 60%, 70%. It depends on the massing. It depends on how the circulation is organized. It depends on how the entrances are configured. That efficiency is far more potent in determining the budget for the gross square footage compared to the usable square footage within it, and that's a design tool. So those are some of the parameters that I feel, in our experience, have been much more drivers of cost than what is the performance target. So then, let's talk about we talked about, is it practical? We've talked about, is it affordable? All the buildings we've designed have been for clients that had conventional budgets. We're going to build these buildings anyway before targeting net zero performance. Let's talk about how best to go about this. I'm going to compare and contrast with some slides a project built for a public agency, the Commonwealth of Massachusetts, and a project built for a private client, Clark University. Both projects had similar aims, but because the public agency has certain laws that regulate how the projects are procured, how the projects are delivered, how the projects are then operated, there are different challenges with each. But both projects were able to be done in standard design periods, approximately a year, in standard construction periods, approximately a year and a half, for conventional budgets. So I can certainly, toward the end of my slides, go into a little more detail about some of the pitfalls of a public project. But I want to move into the slides. I'm going to pause for just a second, and I will during a few times during the slides to just ask, are there any questions or concerns that you have preliminarily? You've come here tonight with things on your mind, and hopefully some curiosity. Thoughts? Both of you, in whatever order you choose.
Have you designed a public safety complex or maybe a firehouse?
No, but I am going to show you some examples. And I want to also say this. I recuse myself from having Architerra considered to design the buildings in the town of Amherst. I do not want anyone to think this is a marketing spiel. I'm not getting paid to be here. I'm doing this because in my heart of hearts, I admire the heck out of all of you who passed this, and I want to see you succeed. But there are many people who have, and I'm going to show some examples.
I don't live in Amherst, so that's fine.
Okay. Where do you live? You're New England? Oh, Williamsburg. Okay, great. All right. Now, you had a question too.
Great minds think alike. That was my question.
We're married.
I didn't know that, really. All right. Yeah.
You said building efficiency.
Yes.
Is that one entity divided by another to get the building efficiency?
Exactly. I should have explained that. It is the net area or usable area, program area, divided by the total gross area that the contractor has to build. So what you take out of it are the things that are commonly used: corridors, bathrooms, stairways, elevators, shafts, to get that efficiency. So it's something you can very much massage as part of the design of the building. Other questions or comments? Please, over here.
Could you speak to solar gain, solar loss? I see a lot of trees being cut down to accommodate rooftop solar. which in the summer, that affects the air conditioning as we're getting warmer. I don't know, but it's a,
Yeah, the question is about the trade-off between solar gain and solar loss. Would it be a wise thing to take down trees, subjecting yourself to a greater heating load, cooling load in the summer, just to gain the power? I have to say, there are other architects in this room who are better to answer this question than I am. Most of our work is in urban settings or in rural settings where, as you can see, there are no trees. This is a former reform school from the 19th century, and for whatever reasons, they didn't believe in planting trees for those wayward boys. So that hasn't been a direct concern of our practice. Bruce or Steve, anybody want to take a whack at it? I think you'd have to analyze it site
yeah,
by
I'm just
site.
curious. Somebody has to have hacked at the numbers.
It's not a question that can be answered in a sentence.
Surely.
All right, but thank you for the good question. Yes?
I would just like at some point in your talk, if you can mention passive solar in regard to the site, because you said site is number one, and I agree with that, and I think that, you know, that's still a consideration that everyone should have, you know, regardless of all of our technology.
The question was about how important the site and siting are to the building's performance. And I would say that I first learned at the knee of an energy modeler who's now out in Boulder, Colorado. But what he taught, sharing a great many energy models that he had developed for buildings that I didn't design or have anything to do with, but just so that I could analyze what could be understood. About a quarter of a building's energy performance, however great or miserable it's going to be, is determined by the solar tuning of the building relative to how you place it on the site and how you orient its long axis. Another quarter is really having to do with the envelope of the building, including your choice about where to put the windows. So many buildings have the same looking windows and sometimes identical window patterns on all four sides. There's absolutely no differentiation whether it's north, east, south, west, and how could that be? We haven't been thoughtful enough. Another quarter is determined by the mechanical and electrical systems. And another quarter are all of those kinds of things that you work out in detail that are sort of architectural engineering collaborations, building efficiency, and how much you're going to have a passive gain versus an active system to cover the heating and cooling loads. So all that by way of saying is, yes, very much a big leg up is where you place the building. And hey, you're going to do that anyway. You're going to build a building, right? So that kind of comes for free. Yeah?
I'm curious what kind of measurements have been used to evaluate performance.
Well, I'm glad you asked that question. How do we evaluate the performance? A couple of us were just talking about this over a bite of dinner. It used to be that long-suffering architects would work with directors of facilities and go into their file drawers and get all their utility bills and make a humongous spreadsheet and do this year after year for no compensation. And that's how we did it. That was pretty miserable, but it got us a lot of education. Now, come to find out, one of these buildings I'm going to show you, I've just recently learned all of the energy data, how much energy the building is using and how much it's generating off a big solar canopy on its roof, gets automatically fed into Energy Star Portfolio Manager, another digital tool, through the utility company. No architect has to call up and ask for this. No owner has to pay for this. It's done automatically. I learned this from a project manager who tediously walked me through 9 months of energy performance and said, you know, Ellen, you can just get this online yourself. Just go to Energy Star Portfolio Manager. And then I found out 50% of the non-residential square footage in the United States is now being tracked this way. So again, in 10 years, it's gone womp. We have a lot more. You can check and find out how a lot of buildings are doing. I not only found out how a building I designed was doing, was curious, looked at a lot of other buildings too. So it's going to become a lot more knowable, kind of like nutrition labels. You can really know what is the granola bar I'm eating actually consisting of and how many calories does it have, and be able to know that. So that's a question about tracking performance and knowing it. Shall we go on? Do you feel like looking at a few slides?
Yes.
Okay. My slides are in 3 parts, and I'll stop after each part. The first part just simply tries to dispense with 5 questions I get asked all the time, in case you're going to ask those questions. Then I'll stop. Then I'm going to talk in a little bit more slide detail about 2 projects. One of them is the Division of Fisheries and Wildlife Field Headquarters, an office building for 120 people. It's in Westboro. Some of you might have been there. It was built for the Commonwealth of Massachusetts specifically to be one of a number of pilot projects to see how zero net could work out. It was done on a public budget. Let's see, make sure that I can get my slides advancing here. About 3 years ago. The other project that I'm going to focus on in the second part of my slideshow was completed just 1 year ago, a little over a year ago, at Clark University. It is I guess you could call it a campus center. They call it their Alumni and Student Engagement Center. So it has like a cafe and a bookstore and classrooms and offices for things like study abroad and honors programs and internships and all that kind of stuff for students. The stuff that's not related directly to formal course credit. Again, designed with the purpose of being a zero net energy building. And while my company, Architerra, was the architect and team leader for both of these, we did them with different engineers, different energy modelers, a different team. And that's just to make the point that there are a whole lot of very knowledgeable people who would love to propose on RFPs for Amherst zero net energy buildings. Not that you could hope to find just anybody able to do this. I don't want to say that, but there are many, many good people of all different categories of consultant that you would need to do any project, including those that are in the offing here. I understand there's a fire station as well as a DPW building. So we know viewpoints can differ. I've already addressed the skeptics and those who are concerned about costs, as well as those who are passionate climate advocates who just want to know how to do it well. But I just want to say that I'm here bearing a message that cheerful pragmatism really works. So if you just get to it, even if you miss by a little bit, you can often make very, very good progress by taking action and fine-tuning the results that you then get. So the number one thing I often get asked is, gee, I've heard of zero energy houses, and I've seen houses with lots of solar panels, but you can't really do a large building. Large zero energy buildings are not possible, but they are. And our practice has been focusing on large scale buildings for about 15 years. Our typical project size is between a few million and 35 million, somewhere in there. These buildings are for a variety of uses: laboratories, classrooms, office buildings. And I want to talk about a couple of them real quickly here. The first I showed were solar powered, but we're also working on a couple of campuses right now that are wind powered. There's a Mount Wachusett Community College project that is entirely powered by wind, where we've completed a science center by finding energy savings to achieve in the adjoining academic center, leaving that carbon neutral campus carbon neutral, so not impacting the energy at all. We're also building on a wind-powered campus overlooking Narragansett Bay in Portsmouth, Rhode Island. This is a campus that is run by a Benedictine monastery, entirely wind-powered. So you can do zero net with a variety of technological resources, and I'll show you ground source and air source heat pumps too. A couple of just examples to get your gears turning about possibilities. Buildings are the problem, but they're also the solution. And what do I mean by that? If you look at global carbon emissions, buildings account for 40% of those emissions. 40%, more than transportation, more than manufacturing. And with global growth rates predicted, global carbon emissions are going to increase by a third again by 2035. No matter what Amherst does, no matter what Boston does. So we've got to get to the heart of buildings and their 40% contribution to that big global emissions pie. And you are leading the way, and many are cheering you on. So here are some examples of how you can think about buildings as contributing to the solution. This is a campus center in Syracuse, New York, which has a hideous number of heating degree days. I forget how many, but something like 7,000. Doesn't have much cooling load though. So this is a building that is used 24/7 by students and faculty. It has a split level roof. The upper level is PV. What's cool about this building is that the lower level has a 10,000 square foot mechanical space that has about 20 pieces of equipment in it that serve the entire campus. It's a multiple fuel CHP, combined heat and power plant, that produces over 60% of the campus heating and 20% of its energy. So it's like a little district energy plant within a building. So the annual savings from this are $350,000 every year. And yes, it costs $2 million more than what we would have spent to right-size that mechanical space for just the building. But that $2 million investment on a 20-year net present value calculation is $1.5 million. 1.5 million. So the more financially sophisticated you are, the more you're very interested in investing in energy savings. And there is a tremendous amount of carbon reduction from this building. Normally you think of a new building adding to the carbon footprint of a campus or a corporate portfolio or whatever it is. This one building takes down campus carbon emissions by a third, just by being there. So that's how you can invert thinking about buildings as being bad. Buildings aren't bad. We need to adapt the designs to a climate that we've long thought was static, but it's not. It's rapidly changing. So we just need to design them differently. Another example, this was a building that was designed with very much passive solar in mind, so lots of south-facing glazing, but all carefully controlled with deep overhangs and that arcade. Very careful daylight studies to make sure there was not excessive heat gain from the west. I'm sorry, I skipped a slide there. This was one of our first projects of a number that we made solar ready that got its rooftop array at zero cost to the owner. And how that happened was a third-party purchase agreement. It happened about 2.5 years after the building was up and operating. So a third party came in and said, for no money to you, just give us your roof access. And we put in all the gubbins to make it work. So it was just kind of plug and play because we knew there will come a day this is going to happen. So when we say solar ready, we don't just mean a rooftop that's got enough structural capacity. We mean the electrical system is ready to just plug in. And that happened. And there's the happy installer. One more example is a technology and design building at Keene State College. This was an unusually cost-effective design for a lot of shops and laboratories and studio space. And it was not able to receive its full complement of solar that it was designed for, so it was installed first module, second module, third module. There's the first module, and they're hoping to get the second module in soon. So that was the first myth. Can you do large-scale zero energy buildings? The second myth, or question I get asked often is, even by architects, soon we're going to have an entirely smart grid. So we don't have to worry about energy efficiency. We don't have to, outsolate these buildings and sweat all these ring-spring details. Isn't that right? I don't agree at all. Energy efficiency matters because capital efficiency matters. We have to be careful that every dollar we spend goes as much as possible into the things that are functionally necessary and delightful for our habitation in these buildings. We don't want to be using any more energy or spending that money unwisely. We need energy efficiency first and foremost. In fact, that turns out to be the key as to how you can introduce renewables on site and make the net production, I should say the energy production annually balance the use of the building. These are some of the stats from the projects that I will have talked about and will talk about in these slides tonight. And I'll make this slideshow available to the town through Anne. And the headliner here is what we found in our work is whatever a code required building would require for energy performance, we typically target a 50% reduction from what the code would require in terms of energy efficiency. When I started my career as an architect, I had the thought that codes required what was optimal. What was optimal. It took me a very long time to understand that's not always true. And very often, it's not true when it comes to energy. We can make buildings for conventional budgets that use 50% less energy than the code requires. And you can see, targeting 50, sometimes we can do better than 50, 60, up to 70%. Sometimes we can't always make our initial goal, but I would suggest for any building that you were thinking about designing, thinking about making it great with 50% less energy than the code would require, and that will get you very close to a zero energy building. Third myth, this is the stubborn bias that, gee, it must cost more to make a building use less energy. Look at this graph of the construction costs. You see Keene State College, the Technology Design Safety Center, less than $300 a foot. Now just keep your eye on the same projects. Here's how much energy they use annually. So I'm going to toggle back and forth. There's absolutely no relation with these numbers. And so, let's look at Keene. Well, it didn't cost very much. It's a LEED Platinum certified. If it had the full PV array, it would be net zero. Why does it use so much? That's entirely a function of the fact that it's got 3 huge shops. One shop alone has 70 pieces of energy hogging equipment. Saws, welding glues, CNC machines, 3D printers, and that building is being used day and night. So performance is much more a factor. What's the building being asked to do? And how are people using the energy within it? All of our buildings they're not seasonal buildings. They are hard workhorse, 24/7 buildings stuffed with people and regularly visited by large capacity audiences for events and functions. So the energy performance is much more a factor of how people are using the building and what the project type is than how much money you're going to spend on it. Next thought is a lot of financial people say, CFOs and college treasurers, well, isn't it risky to invest in one of these newfangled buildings? I mean, the idea of large-scale zero-energy buildings is not brand new, but it's newish. And what we've been finding is really, it's a savvy investment, and more people understand it as potentially promising a huge return, the more they're very zealous about it. Let me give you an example. So I want to show you the calculation made for the Clark Building's rooftop. Here we go, thank you. So those solar panels cost a little less than $750,000. And we ran out a calculation for the college treasurer that showed that with the federal tax credit, with the avoided utility costs per year, with the sale of the SRECs, the solar renewable energy credits, that the NPV over 20 years at 5% would yield an internal rate of return of 11.3%. The day he got the email with all this calculation, he stopped the construction manager and owner's representative from any more discussion about taking the solar canopy off this building. He just said, this is the smartest money in the project. If we do nothing else, and the design, this is the third design. The original design was a very prim and proper red brick thing. The administration loved it. The trustees from California didn't like it. Then we designed something for them, and the donor didn't like it. This is actually the third design. So as an architect, you have lots of adventures. But the day this solar calculation was made, solar was not going away from this building. So investment, which can sometimes be sensed, ooh, is this risky, can often be proven to be very savvy. And now I quickly want to talk about the flip side of what all this carbon is doing. It's causing the climate to change in an accelerating fashion with impacts that have been well documented now all over the world. There are studies coming out showing how much sea level rise, how much inundation by heavy precipitation, how much extra heat are we going to be dealing with. In Boston, as you might have read, where we have summers now that have 9 days, only 9 days over 90 degrees, we are, by the end of the century, going to be looking at 90 days, or having the entire summer be over 90 degrees.
But you'll be underwater, so you won't care.
Well, that's a problem. I'm so glad you made that wonderful joke. The problem of rising seas, and we designed a number of projects in Boston, even having an office at the end of Longmore, I had no idea the sea levels were rising as fast as they are predicted to rise. Some of you are shaking your heads, so you must be brilliant climate scientists, and I am not. My education in this factor came with the International Boston Living with Water competition held just 3 years ago. And the brief for that sounded wacky. It said, take 100 acres. It was a terrible site, kind of scrappy parking lots and barbed wire, broken glass, not much to really push off of for inspiration, but design it so that it will be resilient for 5 feet of sea level rise with a 5-foot storm surge on top of that. We looked at that and said, they must be kidding. They must have just dramatized this to get architects and engineers really excited, or what it did was petrify us. Because we first researched online, this has got to be kidding, right? And what we found out was, it could be so much worse than that. That was a moderate prediction. So designing your way out of that proved a really interesting challenge. And I'm not going to go into it right now, but I'm going to say this is one of our renderings. We produced 22, and we were very honored to receive top honors for this vision. But the goal that's sometimes put out there is this phrase, passive survivability. Have you heard that phrase? I've been hearing a lot at conferences. What we need is passive survivability. We need laws that say buildings have to be passively survivable, but we don't want that. We don't want to just survive climate impacts. We want to thrive. We want a really cool city. We want a really great town. We want beautiful buildings in rural areas. So, this is what passive survivability will get you. I saw this at a recent AIA New England conference, and I said, really? Does anyone want to live in that house? I don't want to live in that house. So I'm just saying, I think our standards for energy need to be soaring. And I think our standards for resiliency need to be soaring. The best is yet to come. We can design our way forward, but we cannot settle for passive survivability. And I don't mean to knock this. I mean, this is important for global and insurance people and so on and so forth, serious matter. But this is not where we really want to wind up. So let me pause for a moment before telling you a little bit about DFW and Clark as a little look-see into the design strategies, and ask if there are any questions or comments or observations at this point. Yeah.
So when you calculate net zero energy, do you calculate the process loads or just the building loads?
We calculate just the building loads. Thank you for asking the question. The question is, how do we define net zero energy? And there are lots of ways. For purposes of this discussion and our practice, we leave process loads, or plug loads as they're sometimes called, out of the equation, but we ride those really hard. Sometimes getting our clients to sign agreements that they know if they goof up the energy performance by plugging in space heaters, bringing mini fridges at every desk, some people want hot plates and printers at their desk. We've seen unbelievable stuff. Laboratories are another. Even if you program central lab support with refrigerators and fume hoods and glass washes to be used, you can go back a few years later and find, this stuff proliferates. If you don't keep a handle on the plug loads, the operations will suffer. I want to mention another thing too that your question prompts, an even higher standard than the one I'm talking about tonight, which considers only site energy, that energy which is used proximate to the building, is to consider also source energy. In other words, to try to offset the carbon from anything fed to the building, from hydroelectric coming from Canada, so on and so forth. I think that's a noble challenge, but that's not been the one that we've been wrestling with for 20 years. So I can't talk about that, but that's a very worthwhile challenge, and one that the passive house standard coming from Europe and now proliferating in the United States holds itself to, and that is source energy. Hopefully the grid will be all clean soon, but we're not there yet. Yes?
I'm wondering if you have to take into account increasing wind forces on the structure of the building.
Yes.
Repeat.
And the question is about wind force. I'll tell you an anecdote. I showed you the project at the Benedictine Abbey. When we started that project, in a concept design, do some renderings and kind of get your handle, your hands or your mind around how many laboratories we need. Sandy had not happened in New York yet. When they pushed the button and said, okay, Architerra, go ahead and design that building, the design wind speeds had increased by 50%. From Miami to Maine, a hurricane zone located 1 mile from any water has taken a hard look at design wind speeds, and I would submit they should also be looking at snow loading too. Do you all remember that winter a couple of winters ago when it snowed, I believe it was 114 inches? That's the first time in my career as an architect I've gotten calls from people for whom we designed buildings 10 years ago saying, how much structural capacity do I have in my roof? And since there's 3 feet of snow there already and it's going to rain tonight, what should I be thinking? I do not want to get that call again. We have to not be designing for historical averages. Looking back 30 years, we need to be looking way ahead, 50 years, and designing for not the averages, but the extremes. That's my conviction. In fact, if I had to stamp one more drawing, I've quipped this a lot, and I mean this. A stamp from an architect or an engineer means this meets the law of the land. I do not believe our laws nearly protect us, and so I'm getting ready to footnote my signature. I don't know what the building inspectors are going to say to that, but I really do feel that designing to codes alone does not protect what our licensure holds us to, which is public safety. So, sorry for the kind of lecture, that didn't sound great.
Are a lot of specialized building construction materials necessary for zero energy buildings that you wouldn't normally use in a building that doesn't try to meet that? And if there are a lot of things like that that go into zero energy buildings, what's happening with the supply chain? Is it becoming more robust? Is it becoming larger?
I'm so glad you asked the question. The question was about the materials being used. And let's start with exterior materials. Some of these buildings that I'm showing, in fact, both of the two kind of case study slides I'm sharing, the DFW and the Clark building are fiber reinforced cement panels that are great for rain screen facades used outside of a thick layer of insulation that's held off from the structure of the building. And the wisdom of that arrangement, which is generic, you can use any materials for the framing and for the insulation and for the cladding. It's very durable and it's quite affordable. But we've also used wood shingles, red brick, commonplace materials for rain screens. You can use some newish materials. There are marvelous new fiberglass. They're called green girts. If you don't want to use traditional framing, we don't often want to use wood in these larger buildings because of the fire classifications, construction types. So the answer is yes, there are newish materials available. You don't have to use them. And yes, to the second part of your question, the supply chain is bringing those on. There are more and more new materials that are well suited for rain screen outsulated buildings. I want to say also the energy systems and solar panels are, I mean, there must be 35 solar panel manufacturers, many people hopping into the heat pump business. There are a good many players. There's a lot of competition. More questions? Well, let's see. How about you again? And then we'll go back there.
Now that there's more active solar, meaning
Yeah.
PVs, has there been a decline of using passive solar? Like on that building, I'm assuming that way where the panels are on top is facing south.
That's exactly
So
what
that long exposure there would be the north, and in passive solar you would have like no windows there.
Well, you're exactly right, and yet what you can't see until I show you the site plan in a minute is all of the great views are to the north and to the east. So we had a real conundrum, and so what we did is we used the wings of the building to self-shade the east, and we opened up that north facade far more than we would have, but still kept it within less than 28%, I think it is. It's a really great question. An optimal design will try to maximize passive and then add the active. So it's still really important. That said, I don't think I would ever vote. Clients can decide differently for cutting off a fabulous view in order to achieve a particular energy performance target. I know there others would disagree. Yeah.
How do you balance airtightness and insulation with breathability of the building?
That's a really good question. I mean, the question is, how do you balance airtightness with breathability? My answer to that is to try to think about them as being delivered by two different things. Airtightness is being delivered by an envelope which is constant, and what did you call it? Ventilation is being delivered through openings, through vents, through fans, through windows that are very carefully designed to not infiltrate when infiltration is not wanted. And increasingly, we're using all kinds of good technological advantages. Let's give the example of interlocks with windows, so that there's a sensor when the window is open, the ventilation system is cut off, so the building is no longer guzzling energy to try to ventilate itself or heat in any manner with the windows open. Is that answering your question? Okay. All right. Should we look at a few more slides? Okay. So you might wonder a little bit about this DFW building. I know some of you, I know, have been to this building. It's a building, as I mentioned, for 120, mostly biologists and other types of scientists. They do regulatory work, so if you have a project that needs permitted, you might go there to get the permits. They do research work, they do public education work, and they do a lot of conservation work. We used a lot of different strategies here to, even where the footprint is very wide, to introduce daylight to a very inexpensive means, a shallow dome skylight. There are a series of them, rimmed with very affordable acrylic sheeting. We call these luminaires. It amplifies the light. They look like artificial lighting fixtures, but they're daylight. There's no light source there other than the sky above. There's a masking white noise provided by a two-tiered trout pond. It was not our idea to have trout living in the building, particularly not when we understood their temperature requirements. These need chilly waters. But the conservationists said, no, these guys are the ones who run the fish hatcheries. And they, we actually had them understand that we've never kept trout alive in a building before, so they would take full charge of that. So this building has a different quality than most state office buildings. We were really astounded. There have been, I think now 4 couples who've been married in this building. That's pretty interesting. So how did it all come about? Bruce Coldham and I and about 60 other hardy souls gathered about nearly 10 years ago now at the request of the governor to bear down on how could we create a roadmap to get the whole state to be doing what you're all doing, which is zero energy buildings. And the state's leadership, just like the town of Amherst leadership right now, makes a tremendous difference, because when all eyes are upon you, you are going to rise to that challenge. And the public, if you can make the process an open learning one, will gain an enormous advantage from the effort of having that leadership be attentive. Second thing is a strategy that I would recommend. I think very little design effort focuses on programming. And what I mean is going beyond just a spreadsheet that says these are the spaces we need. We need so many offices, so many conference rooms, so much storage space. There is inevitably fine-tuning of that program that we think helps people not build more square footage than they really need. Our effort is to try to not build the initial going in square footage that people say. People often say, we need a 60,000 square foot building. We say, why do you think so? And when we look deep into their numbers, it turns out, oh, why do you need 8 conferences? You know, well, we have 8 departments. Well, can't they share 3 conference rooms? Laboratories are the same way. Every lab needs a prep room. What's in the prep room? Same thing. Well, how often is it used? Well, once a semester. You know, we need 80 fume hoods, and we can get it down to 8. You know, fine-grained programming only takes a few weeks, but really asking hard questions and not necessarily believing that clients are right about what they need. It's a very interactive process that teaches an enormous, teaches a great deal that then goes into the energy modeling for these buildings. So there was a lot of programming that went into making shared use spaces for this project. Siting and massing, as I mentioned, can account for up to 25% of a building's performance. So we made sure to run the long axis of the building east-west, put the broad side to the south. As I mentioned, you get a sense of it here. 1,000 acres of wildlife management land lie in this direction, to the north and the east. And we put all of the communal spaces, the break room and the staff lounge where everybody could enjoy that. You can see we opened up the side here. So our buildings often wrestle, sometimes agonizingly so, about how to differentiate the glazing. And our rule of thumb would be, typically, the south would be 50%, and the east and north, you know, about 20 or 25%, and the west 10% or less. West being the most unmanageable, harsh glare, high heat gain. But here we vary that rule a little bit and use the massing of the building to provide some self-shading on that east facade. And this is just a little bit of a depiction of how we're using the eaves to not only control the gain on the south, but also the mass of the building to shade the glazing on the main entrance. The glazing being an architectural device to let you know where do you go in, how do you enter the building. This was one of the first uses of SIPs, structural insulated panels, for a non-residential building that we know of. It was our first attempt. So the building went together with absolutely modular, 4 feet wide by 14 foot high, sort of sandwich panels, really, really tightly butted and carefully sealed. And that sealing was assured by 2 things. One, a mock-up, so that people could really get how to rain lap the tape and get the sealants in the corner and understand how it was going to leak. And then testing. The mock-up was tested, and then the building was blower door tested for air tightness. And this building tested to a tightness standard that exceeded Passive House. The high performance systems included ground source heat pumps. There are 20 400 deep wells, 400 foot deep wells in the parking lot. There is a mechanical pen on the site that screens a chiller. The air handler and the enthalpy heat wheel is located in a lower level mechanical room, and then we have some mechanical equipment on the deck. So we think very creatively about not only the system components, but the system integration with the building. As I mentioned, we put a lot of effort into daylighting and accentuating the views, and that's just a little reminder of that. As I've mentioned, there are solar panels that cover the entire roof, but for a well in between the two wings of the building where we have the fan-assisted ventilation. There's the parking lot location for the wells for the ground source heat pump system. Turns out solar systems come with a lot of very ugly components, and we work hard to hide them. You're looking at a row of what are 17 inverters. These are like shallow refrigerators, and they're really ungainly. There's an emergency electrical on-off switch. The fire department needs to be able to yank on that and kill any power flowing from that roof in order to be able to fight a fire. Those are beastly, and they're required to be right next to the front door. And here we negotiated right next to the loading dock door, but we've always put those in a niche. They not only look better, but they don't get hit by a pickup truck with a deer that's trying to get to the deer weighing station. So how did this building do? We've been tracking this for a couple of years. We don't have the third year. It's now been operating for 3 years, but it's been operating close to its target. Not quite. It's fallen a little shy of it, but nearly 100%. Now, compared to modeling, I want to talk about this a little bit. It's really hard to make a model that predicts human behavior, weather that includes electrical storms and snow ungodly high. But the actual energy use was 21% more, in part because there are up to 4 events daily on average that have nothing to do with the people who work in the building. So it's like the Northeast Energy Partnership coming, or climate scientists from Rhode Island. People are there touring the building. So the building is quite a bit more used, including on the weekends, than we ever imagined. And PV generation was 7% less, and that included that time span where the heavy snows were. So then quickly looking at a compare and contrast example for a private client now, I've told you the investment story, the attitude about that solar canopy. The building on the interior includes an arrangement of spaces that are very modular. Every space is either 1 up to 8 modules big, so it's designed for really flexible use over time. All those non-load bearing walls can be reconfigured easily. After we got rolling on the design and declared our intention to incorporate solar in some sort of roof canopy, we applied for and won a zero net energy grant from the state with $350,000. I think Amherst might avail itself of other types of state programs. There's a constant changing constellation of programs by utility companies as well to try to encourage these projects. The site is right on Main Street in downtown Worcester. It's a very urban site. It's right on the sidewalk line. We have all kinds of issues interesting with respect to negotiating good partnerships with the neighbors and also getting town approvals for side yard setbacks for the canopy. There it is under construction. It doesn't use SIPs. It uses a alternating mineral wool insulation, staggered joints, and rain screen. Our sweet spot for glazing is to have no more than 35% as our target window to perimeter facade. That's where we always aim. This one was a little higher, and it was higher for a particular reason. The trustees really wanted a very glassy south end, and we wanted to be true to our goals and make it only 50% glass. If you look closely here, you can see the vision glass is clear. The spandrel glass, though, is solid wall. So let me just toggle back. So take a look at this spandrel glass right here. That's actually, with the full backup wall, performing better than the rest of the rain screen facade. So it's a little bit of sleight of hand. We use spandrel glass on the outside, but a backup wall that's heavily insulated. So you can have the glassy look, which has a very pronounced open feeling from the campus, which is on the other side of Main Street. So we understood the architectural reason for doing that.
What
That's
is
the
spandrel
facade.
glass?
Spandrel glass is simply, it's not vision glass, it's a full height panel that is colored glass, pigmented glass. Pigmented glass. Comes in a lot of colors. If you use a blue-gray, you can, or sorry, green-gray, you can get the appearance of glazing if you compose it that way. To lighten up the appearance of solar panels and make an architecturally interesting statement about this soaring canopy, we rimmed the canopy with some printed glass, that is enamel printing, which keeps it from ever looking dirty, which was a concern of ours, and also makes the PVs themselves all accessible from the roof surface, the walkable roof surface directly below. So we did a lot of things with maintenance in mind. This building incorporates air source heat pumps, so those are all hidden behind the facade screens there. They're not low down, they're up, which is a good resiliency strategy for buildings that are, this one is not located on the shore, but getting mechanical equipment up is going to become increasingly important for many, many of our buildings in cities which are in coastal areas. And even within the context of a lot of 19th century architecture, this contemporary building, I think, is a pretty happy one. I mentioned the 100% light emitting diode LED lighting before. A number of buildings we've done, this is one of them. Allows us to achieve a connected load lighting power density that's less than half of what the energy code requires. And this building is plenty bright. It has gorgeous lighting fixtures and it has a good level of illumination. Another thing we do to make the use of electrical lights less a necessity, it's a choice. You might want to brighten the room if you're having a large meeting, but you might not need it, is to introduce a lot of transparency. Those are interior partitions that are glazed throughout. So in its first year, this building does not have a parking canopy, a PV canopy over the parking lot as it was designed to get. So our target was 70%. It produced 68% in its first year. Again, you can see this on Energy Star Portfolio Manager. The actual energy use, you can see we're getting better at our modeling, was 10% more than was modeled, but PV generation was also more than was modeled. So getting all the parameters, what time is the building going to open, how many people are going to be at their desks, how many public events are you going to have on the weekends, what is the admissions department going to want to do in this building that we haven't thought of. It's hard to predict human behavior for a largish building that has hundreds of people and 1,000 pieces of furniture, which is an example of this building. So that's the story on those two buildings. I would just observe that you absolutely can do large-scale zero-energy buildings. I forgot to mention something that's critically important, and that is that identically designed buildings, numerous studies have shown this, can be operated really well or not so well, and human behavior in the operations of buildings makes a threefold difference. Buildings will vary by as much as 3 times depending upon how they're used. So think about a Prius. A Prius might be designed to get a certain mileage, and that's advertised to you when you go to the showroom. But if you drive with a lead foot and go 90 miles an hour, you won't get anywhere too close to that advertised mileage. Buildings are the same way. How they're operated is very much within your control as the owner. There may be public bidding laws that you are subject to that require you to take the low bidder. We would encourage, if that's the case and I don't know enough about it, to make sure you think up some way to pre-qualify those people and to ask them lots of detailed questions about their low bid to make sure it's a bona fide bid. Make sure that they really understood the systems and have given you everything on the spec. Some bidding laws for public agencies require that the specifications, in order to encourage a lot of pricing competition, allow 3 equals of absolutely everything. And our point of view is born of conviction of the school of hard knocks, is some things should be proprietary. I mean, if you really need a very high efficiency sun power solar panel, go for it and put in your specification. That's what we want for our new fire station. We don't want equals, we want just that one thing. And one final point I would make is private clients have been doing building commissioning for 10 years or more, and they get it. But commissioning, which is an engineering service, sometimes offered by design engineering firms, but sometimes offered by commissioning firms, to get the building working the way it was designed, to get the air source heat pumps and the solar system and the building management digital control system all working perfectly. That's a service that you should plan on procuring. And you should do it maybe not just once as part of the building construction, but a year again when you've discovered some of the funny things that we have found, sensors that are wired for and installed but not connected, things like that. It's hard sometimes without running the building for a little while to pick up on that. It looks good. I wonder if there's anything in this building that's like that. It's hard to tell without running it. Okay, so are there any questions? We don't have too much time, but I want to share a couple of examples of fire station DPW facilities. Yeah?
Do you do anything to insulate the glass at night? You know, these large
Really good
expanses of glass.
Yeah. We do not, but you could. We have interior shading, so there's and again, they're all triple glazed. Did I mention that? I'm sorry. The question is about, do we do anything to shade the glassy areas at night? I think I said, or I meant to say, that we have not designed a building in 15 years that doesn't have triple glazing. So that triple glazing with a good German-made window might have an R value of 7.5 or 8. So it's a lot more comfortable than double glazing. We do have interior shades, but they're not going to give you much insulated value. We have seen and admired designs of buildings that have insulating closure panels on the outside. Our experience is that stuff outside in New England just is asking for a callback again and again and again. So, yes.
I've seen that different towns, different areas have different net metering policies.
Yes.
And that's really important with a flat roof like that, because you get so much more energy in the summer than you do in the winter.
Yes.
What's the net metering policy in Worcester?
In both cases, the question is about net metering. The net metering policy is changing, and we should all be advocating, I think, for a relaxation of the caps and the rigmarole you have to get through. My own personal experience is it takes about a year and a half, which is longer than it takes to design the whole building. And there are 3 steps to it. You need to get the sales agreement. That's sort of the business end of it. Then you need to get the real estate department of your utility company to agree to an easement to access their switches and stuff. And then there is an administrative part of it that ties that all up in a big folder for a kind of closing thing. And as an architect, I'll tell you, I wasn't trained to do any of that, and that is a really hard stuff to do, and it should be easier than that. But battery technology, remember, is coming soon. Not that we won't need to have buildings off the grid, but when we can bank our own energy right there on site, up in the open air mechanical gallery or down in a mechanical room on the first floor, and have that be our repository for the excess energy you're mentioning, that'll be wonderful. Yeah.
The hassle there, though, is the grid is a huge battery.
Yes.
So it will store a lot of energy from the summer that you can use in the winter.
Mm-hmm.
And to put a battery that big in your building is going to take up the whole basement.
You think?
Yeah.
That's not what it's for. It's to do what you said.
Well, stay tuned. More questions? Yes, here.
Can you talk about the difference between the SREC program and the SMART program? I'm trying to understand the SMART program.
Oh, man, I just went to a program about that. The question is about the SREC program and the just passed SMART program. I don't know the details, but I do know the email addresses of people to ask. I went to a seminar, I took about 90 pages of notes, it felt like, and I still don't understand all the particulars enough to advise clients. But I will say what I've observed over 20 years is that there is an ever-changing sort of flavor of the month, bunch of promotions where you can get grants, you can get subsidies, you can sell credits, you can make money to advantage a project, and it's really worth researching that as you start every design effort. And if I become expert one year, I can't use any of that knowledge for a client that comes the next year because it's changing. So, I mean, I think you should be first in line for both, and the SRECs are only going to get better. But the SMART program may be ancillary. I don't even know how they interact.
I thought the SREC program was essentially for commercial projects gone.
You may know that that's going to be replaced directly. I don't know that.
So let's take a couple more questions.
Yeah.
Perhaps an easier question about SRECs. In my mind, it seems that if you're selling the SRECs from your solar production on a zero energy building, then in the theoretical world, isn't the building no longer zero energy because you sold that credit to somebody else? And it's their solar on top of your roof.
You're right in how you're thinking about it, but that's not how every client thinks.
Right.
Yes.
My mind is blown from this conversation. I'm
so
wondering.
sorry.
So there's been so much, and you've done it in such an agile way. You've covered a lot of ground. I wonder how many of the architecture schools in New England, and let me add New York State. I often add New York State into it because my congressional district reached the New York border. How many of them are teaching this stuff?
So this is a question from our
architectural education.
U.S. Rep. John Olver asking.
Question about architectural education. We should ask Steve to answer that, but from a hirer's point of view, all of them are teaching it.
All of them.
To some extent, some of them better than others, but this has been transformational.
It's an answer from the John Olver design building. Is that all architecture schools are to be accredited or required to teach a working knowledge of net zero sustainability resilience?
You know, what impresses us so much is, and at least our predisposition about hiring is when folks come with a recent architecture degree, we're not really looking for what they know or what they've designed, but what questions they ask. Because we're all on a learning journey here and we're all perpetual students. To make anything this innovative happen, we've got to be curious, we've got to be tinkerers, we've got to try stuff, but mostly we have to act. We can't be too afraid to act. And I do really believe that buildings are the answer as much as they are the problem.
One more question here.
Well, I have a comment and a question. The comment is that my daughter graduated from Yale Graduate School of Architecture 5 years ago and learned zero about this. They didn't teach anything.
Really?
That was 5 years ago. Now, I don't know if in the past 5 years it's, it's...
Hopefully.
Oh, yeah, hopefully.
I think Steve would,
Been a sea change, and I don't mean that in a...
Yeah, no, well, I'm glad, because I used to ask her. I used to say, are you learning any of this stuff? And she said, no. It's a very classical architecture program, no, we're not.
It's different now.
But my question is, with those south-facing windows,
that are so wonderful and provide so much light and all. It kind of piggybacks on the question of, night shading for loss of heat. What about all that heat in the summer from those south windows? I don't see, you said triple glazing, but is that enough? Does that have?
Some buildings that I could have shown but didn't have exterior solar shades, either grills or blades that come out of a dividing mullion. Those happen to be two projects that don't have that. Other things you can do have to do with different eave designs that can break open into trellises and whatnot. It's a very good question. How you control the passive solar energy is just as important as how you let it come in. Yeah.
So I want to thank Ellen Watts for speaking with us today at such a cheerful, pragmatic level and tone, and we look forward to more events coming up. Our next one will be on February 20th, and we'll be hosting Darren Port of the new Northeast Energy Efficiency Partnerships. And he can answer some of the questions that have been asked here in more depth about policy and about the long road that we've come and where we're headed, because he has the whole Northeast is his jurisdiction. He's helping municipalities and states to do this work in large scale. So we hope to see you there. We'll email you about it. And I think Ellen probably needs to get back to Boston, but if you want to hang out, I'm sure lots of people will have questions. If you want to scoot out, I'll help you. So thank you.